Let's find the complex zeros of this higher degree polynomial. This time I use a fifth degree polynomial. According to the fundamental theorem of algebra, so this fifth degree polynomial has at least one complex zero. So at least one means one or above. Okay, so this is a higher degree polynomial. I would like to use the rational zero test or rational zero theorem. The first step is finding all the possible rational zero. So we set up a fraction. The top we are looking for the factor of the constant value, which is a -9. If this is a +9, then this is a +9. And then the factor of the leading coefficient. This is the leading term. Phi is the largest degree, so the entire term is a leading term. The number in front of x is the leading coefficient. So -9, it can be 1 times -9 or -1 times 9, right? It can be a -3 times +3, so we have to take care of the plus and the minus. So this will be a ±1, ±3, ±9, and then 1 is just a ±1. We have to take care of the plus or minus because -1 times -1 equals to 1. So take each number on top divided by 1, so that gives you ±1, ±3, ±9. And then the next step is you have 6 numbers, right? 1, 3, 9, -1, -3, -9. The next step is you have to find out f of which value. So when you plug in that x value, the y is equals to 0. I know it's a lot of trying. That is what you have to do. In my class on a test, so let's say in person written test, I would just give people like 3, 4 numbers to choose from, and I always hide the one that works in the second number. So they try the first one that's not going to work. When they try the next one, that is going to work. So in that case, every student has the right answer. I will just make you to try 4 numbers. So in my class, on my test, I will give them 4 numbers to try, and I will say try this only. And then I will put the number in the second one. So when they try the second one, oh, they will say that works. Okay, in here, I already did the problem. I know that when x is equals to 1, y is equals to 0. And then you move on to this. So you move on to g of x equals to 1. So when you plug in x equals to 1, you get a 0, right? So that tells me that x minus 1 is one of the factors. What do I mean by that? That means g of x is equals to x minus 1. So this is one of the x. That means the remaining factor, the highest degree is 4. And then the rest, I don't know yet. Because 4 times 1 is not 4 times 1. X times x to the 4th, 4 plus 1 is equals to 5. The rest, I don't know. Okay, let's find out what is the ... So we will be using synthetic division. So this is a x minus 1, and then we put a 1 right here. The sign is always the opposite. If this is a plus, then this is a minus. And then the rest, synthetic division, I only need the coefficient. So 1x to the 5th minus 3x to the 4th, positive 12x to the 3rd minus 28, 27, and then a 9. So the first number, you just pull it down, and then 1 times 1 is 1. Negative 3 plus 1. Negative 2 times 1. Add them. 10 times 1. Add them. Negative 18 times 1. Add them. 1 times 9. This is 9. When this is the 9. Oh, the constant is minus 9. Sum is equals to 0. So this is a remainder. It must be equals to 0. The remainder must be 0. Otherwise, the x minus 1 is not a factor. And when x is equals to 1, y won't equals to 0. When x equals to 1, y is equals to 0, then the remainder must be 0. And then the rest of the numbers, this is the constant, and then minus first degree, and then second degree, and then third degree, and then fourth degree. So now, do you see the ... This is the ... So I mean not including the fourth power. All right, so not including the fourth power, so this piece actually goes here. And then other than that, I also find out that when x is equals to 1, so in here, when x is equals to 1, y is equals to 0. So that means I have to bring this over here. So that means we have another, so x minus 1 is another factor. So this is a 1, and then the rest, I will just pull this line here. So 1 minus 2, so we have a 1 minus 2. Let me, hold on. You know what? I think it is better to use a different color. I think it is better, but if you already copy it, you don't need to erase anything. I think it is better to use a different color. So this, when x is equals to 1, y is equals to 0, so you have x minus 1. This is another factor. And then we keep working right here. So this is a 1, and then the rest, we pull the 1 minus 2, 10, negative 18, and then 9. So that means we will be taking this fourth degree polynomial divided by x minus 1 to find the third degree. Okay, pull the 1 down, 1 times 1, add them. Negative 1 times 1, add them. 1 times 9, and then you add them. Negative 9 times 1, sum is equals to 0. The remainder is equals to 0. So we started at the fourth degree. After you divide it by another factor, you have a third degree. So minus 9, first power, second power, and then the leading coefficient, x to the third. All right. And then right here, and then at this point, let's switch to a different color. When x equals to 1, y equals to 0. So this x. So that means we can start another line. So that means we have x plus 1, and then another factor. Another factor. So this will be a 1, and then we pull this line down. So 1, negative 1, 9, negative 9. So I am taking the third degree divided by x minus 1, so I will get a second degree. So this negative 9, I erase a number, right? Negative 1, 9, and negative 9. Pull the 1 down, 1 times 1, add them. You have oh, you know what? You can do this, or you can do factor by group. So negative 1 times 1, and then hold on. You know what? This I will just do factor by groups. 1 times 0 is 0, 9, 1 times 9, and then add them. So this will be a 0. And then this is, you have a plus 9. The first degree is missing, plus 0x, and then you have 1, which is an x squared. Second power, first power, constant. So you have an x squared plus 9. Okay, so if you don't want to do another synthetic division, here is another way to do it. You can do factor by group. So x to the third minus x squared plus 9x minus 9. You can take the x squared out. These are all long problems. So x minus 1, and then you plus 9, and then you have another x minus 1, and then you pull the x minus 1 out, and then you have x squared plus 9. So we have a fifth degree, right? So the fifth degree. So let's do the g of x. How many x minus 1 do we have? So here are my factors. I have that line right over here. So this one, I will just put it right here. So you have x minus 1, and then x squared plus 9. And then before that, I have another x minus 1. So x times x squared, you have x to the third. I am still looking for 2 more. You have 1 right here. and then you have 1 right here. So you have x minus 1 and then x minus 1. Now, here is another problem. How do I make sure that I pick up all the factors? Look, this is a long problem, which is the intention of this video. I want to demonstrate a long problem. Okay, did I pick up all the factors? Let's check. The highest degree is what? The highest degree is 5, right? Look, x times x times x. So this is a x to the third power. The third power times the second power, you get a fifth power. So this is a check that I just pick up all the factors. Did I factor completely yet? The answer is no. The next step is I need to factor this. So I need to factor this. How? Okay, this is something that you need to know. Okay, so let's set that equals to 0. So we set that equals to 0, and then we need to factor that. Okay, let's do that in red. So we have x squared plus 9. Remember that a squared plus b squared cannot be factored, but here is the secret, which is something that I want you to know. So this can be factored into x watch plus the square root of negative 9, and then x minus the square root of negative 9. Is that going to work? Yeah. X times x, you have a x squared. Now, follow. You have a minus, right? X times the square root, this is a minus, and then you have a plus. The minus and the plus get rid of each other, and then you have the plus times that. So maybe I should do it right here. So plus this, and then you multiply negative that. So this gives you what? A minus 1, and then you multiply square root times square root. Basically, you remove the square root. So this gives you a plus 9 back, which is right over here. Okay, so now let's factor completely. So to factor completely, I'm going to back to my original color. So this you have a x minus 1, basically three times, right? X minus 1, all right, x minus 1, and then you have a x plus the square root of negative 9. Okay, the square root of negative 9, what is this? The square root of 9 is 3. Square root of negative 1 is I. So this is a 3i, right? Okay, so you have a plus 3i and then x minus 3i. So this one is factor completely. And then when you set the whole thing equals to 0, you have x equals to 1. So this is a repeated 0 because repeated 3 times, 1, 2, 3. So this is a repeated 0, and then you have x plus 3i equals to 0. So x equals to negative 3i. So x equals to 1, x equals to negative 3i, and then x minus 3i equals to 0. X equals to 3i. So you have two complex 0. Complex 0 has different names: complex zeros, complex solutions, complex 0, complex solution, and complex root. Okay, but when you do the graph, you will only see there is one x-intercept at x at 1, 0. You can graph this. So go back to the very beginning, just put this into decimals or your graphing calculator. You will see this only. X equals to 1 is a repeated 0. There is one x-intercept at 1, 0. All right, so that is the end of this video. So when you see this, make sure you know how to factor completely x squared plus 9. So if this is something that you would like to see, click the thumbs up, subscribe to my channel for more contents like that, and otherwise I will see you all in the next one.